So there are 5 candidates. There are 2 town council position seats to fill. 3 of them, of the 5 candidates, are for the removal of a landfill just outside of the city. The same candidate cannot fill both seats. Okay, so in letter A, we want to know the probability that a randomly chosen candidate is for the removal of the landfill. So we'll let F equal for removal, and thus F bar will be not for removal. Okay, so the probability that somebody is for removal, well, there are 5 candidates. Of them, 3 are for the removal of it, so there's a 3/5 chance. In letter B, given that one of the positions is filled with a candidate in favor, so given that it's filled with a candidate in favor, we'll call that seat 1. With this, I'll put a little subscript down there. What is the probability that the second candidate chosen is also in favor? Okay, well, if the first candidate chosen was already chosen, that means there are 4 people left to choose from. Since the person chosen was one of the candidates in favor, well, now there are only 2 candidates left who are also in favor. So there are 2 out of 4 people left who are in favor of the removal of the landfill. In letter C, what is the probability that 2 candidates in favor of the landfill removal are chosen? Okay, well, so we want to know basically if the first and second people are both in favor of the removal. Well, so we want probability of F1 and F2. Okay, well, first that starts off with the probability of F1, the probability that you choose a person who's in favor, times the probability that you choose a second person who's in favor, given that one of those people has already been selected. So we actually know these numbers. They are a 3/5 chance for the first round times a 2/4 chance for the second round, and that gives us a total of 6/20, or if you reduce that, you could do 3/10, so a 30% chance. Letter D, we want to know what is the probability that only one seat is filled by a candidate in favor of the landfill removal. Well, this is where it could be tricky, because what do we mean by only one seat? Well, that could be the first seat, it could be the second seat. So I think it's helpful sometimes to either draw a little 2x2 table with maybe candidate 1, candidate 2, and then the possibilities, favor, not favor, favor, not favor. But I'm going to build a little tree, so I'm going to say, okay, so here is either first candidate can be in favor or not in favor. If the first candidate is in favor, then the second candidate can be in favor given that the first candidate was in favor. Similarly, given that the first candidate was in favor of this guy, the second candidate may not be in favor. That's a possibility. Given that the first candidate was not in favor, well, you still have the same possible outcomes. The second candidate may be in favor, he may not be. By the way, it's just the same thing to write F, F bar, F, F bar. You don't necessarily need the conditional part. That just emphasizes that it's conditional upon the first person having been selected. So we know that in this case, there's a 3/5 chance that you're in favor, 2/5 chance not in favor. Well, again, if the first candidate is in favor, the likelihood that the second is also in favor is 2 out of 4. 4 candidates left, 2 of them who can still vote in favor. Well, to begin with, we didn't remove any of the candidates not in favor, so there are still 2 left, but we've chosen a person who is in favor, so that also comes out to 2/4. Okay, well, if the first person chosen was not in favor, that means there are 4 people left. What is the probability that the second person is in favor? Well, there are still 2 of those characters left in the left over. Excuse me, 3 of those characters still left over. None of those have been chosen, so there are still 3 out of 4 people who can vote in favor. Well, given that the first person did not vote in favor, that still leaves 1 person who can vote in favor. So this comes out to, if you multiply the probabilities, 6/20, 6/20, 6/20, and 2